Today we're not gonna start with a finished project that I'm just gonna write test code in. Today we're looking at organizing projects and actually organizing multiple libraries and spreading your code across multiple projects in general. To start off, just a quick feature that most IDEs should have. I know you can't see my context window, so I'm just right-clicking on the solution right now. Don't care about that one. And I'm adding a solution folder because I want to organize a few projects in one go. And just gonna call it like that. And then I'm gonna hit right-click again, add new project. And this window we can actually see, hopefully. There it is. So this is the default window we get in the current version of Visual Studio for creating new projects. You can see what type of projects you've recently created. This is my look right now, because I've been experimenting with a few things. Some projects I should restart. Anyway, let's create another console project for now. Just gonna call it main program. Gonna use .NET 9. I don't like top-level statements. That's in there, and I'm going to quickly change the CS project because I don't like implicit usings either. So I'm just remove that. And we're gonna add warnings as errors, nullable. That should do the trick. Add the reference. Let's quickly see if that works. String a equals null, that should complain. Yeah, that's an error. So, setup complete, I have a new project now. And this project is just a simple executable. Output type is exe, because this entire project, main program, when compiled, will generate an executable file. A program you can just run, at least on Windows. That's what it's going to compile for right now. Well, I could actually specify it being Windows. Different story for another time. And while a single program is perfectly fine, or a single project for your program is perfectly fine, that might be the best approach for what you're writing, especially if you're writing something small. It's likely the best way to handle it. You sometimes want to organize your code a bit more by spreading your code across multiple projects. So even though it's a single program in the end, it's a single program with one single executable you're running, that you're executing, the source code might be spread into multiple projects. And there are various reasons why you might want to do that. First of all, for organization. That's not the best argument, it's actually the weakest argument, because we can inside a project also just add folders to spread our code and organize things. That's not an issue. So going for different... Oh, that worked. Weird. Sometimes it's not showing the windows when I click on them, sometimes it is. I have to... Nah, I knew it. We're not gonna use that feature in future episodes, I think, so that's fine enough as it is. Where was I? So, yeah, organization. Just to make your code more organized, that's a weak argument, because you can already do that with a single project. And adding multiple projects just for organization, that's actually less organized than just a single project. But you might want to have different settings for the code you're writing. And one of the biggest factors might be the targeting version, the target framework, or more specifically the C# version you're using. Let's say you have some legacy code, some old project from years back, and you want to use that in your current program. But my current program uses now a new feature that was added to C# in the meantime, And I want to make use of that feature, so I specifically enabled it. By default it would be off, but I enabled it because I want to make use of it. The old code was written without that feature in mind because it didn't exist back then. And to use the new feature, I would have to migrate my old code to make sense. In my old code, for example, this string could be null. And if I just copy pasted that in here, the code would only work if it can be null. But I enabled nullable, so I would have to go through my old code and change that everywhere. That's a lot of hassle. I don't want to go through that. I could also decide I'm not going to use the feature, but that's also a drawback. That's a good feature, why should I not use it? Also, maybe it's a feature I need. Nullable is not the best example, but maybe there are settings in here that you absolutely need that were only made available recently, and your old code simply cannot deal with that. So you spread that out into projects. I can make another project now. Let me just new project. And this one, I'm just going to use class library. Main program. No, let's call it just library. Very creative. And let's use .NET Standard this time, which is a different framework. .NET Standard is a bit special. Let's just first create it. There's a default class in here. Sample class. Ignore, please. I mean, I don't have to actually add a class. It's just in there. Let's also rename this. This is just... Let's just rename this quickly. That's better. Just to have something. So if I go on library and compare the two main program, we only have the target framework now, standard 2.0, compared to .NET 9.0, and I don't have the output type, and nullable is not enabled. So in my sample class, public static void some methods. So if I go string a equals null in here, that's perfectly fine. And actually, we're gonna make it so we return null. We're gonna use that later. So by placing my old code in a separate project, specifically a library, remember I set it as class library, not as console project. That's why the output type is missing. It's just a default output for DLL, dynamic link library. It's just a library. That way I can use my old code and still use the new features. Which means I have to somehow connect these two projects together now. I have my main program in here, but I want to use the code. But the code is over here in this other project. And projects themselves are, at least usually, spread into their own directories on your file system. Like in my actual file system on Windows right now, these are two separate directories. Placed within the same root directory for the entire solution. Doesn't really matter. But these are isolated from each other. So they don't know about the other one. They don't care. I can now decide my main program should have a dependency on this library. And I can right click on my project and go to add, go to ProjectReference. Again, I know you can't see my context menu. I'm just right click on it, go to add, ProjectReference. That's a menu with 3 dots. And that will open this little window, which you cannot see. This one didn't appear automatically. Let's just correct that. And this should do it. Now you can see it. Now this little window, the reference manager, allows us to do some really cool stuff. For starters, on the left we have a couple of categories. We're now in projects. That's the one we care about. Projects within our solution. We could technically go to browse in the bottom, the button, and select a specific CS project file, but I'm only caring about the library that's right next to me in my solution that's already available. Actually, let's do something. Let's say I'm gonna do this one. I'm just reloading this library of this project. If I go to add project reference, it's available as well now. Just usually I unload these. You can also right click any project and unload project to just basically deactivate it. The code is still there, all the files are still there, it's just Visual Studio will ignore it. Or pretend it's not there. But it is. And the same way you can right click on any project and reload it. Just to activate it again. Now to go back to add project reference, you can see the path where the CS project file is located. And I will just check this on, hit OK. And if I go to main project now, you can see this extra block of code was added. At some point we're gonna talk about MS build and what these groups actually mean, but the important part is we added a project reference. It's in here now, and because of this project reference, you can see there's a path in here, a relative path. It will start at the location of our main program, where our CS project file is located, the file you're looking at right now. It will go up by one folder, one directory up. That's what two dots are standing for. And on that level, go to the directory library, which is this other CS project file, or that's the other project, and within there is the other CS project file of the same name. So we have kind of hard-coded a relative path from main program to library. This way, main program knows about library. Library doesn't know about main program though. It doesn't need to, it doesn't care. But because we have that, we can now just go to example, public static class. Let's just do this. Okay, let's the full rename. That's better. Now I can go example class. I'm using the IntelliSense, which knows example class exists. It knows all my reference projects, and it automatically added the using statement I need on the top. Example class.SomeMethod. And I can store that. And I can call SomeMethod. Now, here's something slightly dangerous. I switched to a separate library because my original code doesn't know about nullable, the feature. My new code does. And the old code, just a string, meant it can be null. And the new code, just a string, means it can't be null. So I'm storing some method which can be null, which is a string, but I can't store it in a string. Not reliably. I mean, I can try to call this code. I can actually try to compile, and no errors. Compiler didn't see any issues with it. You can also call the program, and this too didn't see any issues with it. The compiler compiled successfully because it assumed, yeah, types match. This is fine. So even though it's not allowed, some method suddenly contains a null. Reminder, the usual feature would be null is an error. This can't be done. So if I do something with some method, example check the length, this is safe code under my new rules with nullable and program. It's not safe in the old system where some method could be null. So if I execute this code, we get a null reference exception because some method is null. So if you use some external libraries, you have to keep things like that in mind. Like the most important, at least for right now, is nullable. So what I should do is mark this as nullable in my new code. Some method is specified as just string, not string question mark, because the old code doesn't know about that. I just have to keep that in mind for my new code, where I have to specify that now. This code will still break, but at least I'm aware now that some method can be null, and I know, oh, maybe I should add some defaults or some error handling or whatever. We can deal with it. So there's slight danger, but this way we can actually combine the old code without nullable and the new code with nullable, but just spacing that out into two separate libraries. And looking down here in the line, there's another advantage you might have. By spreading the code out into multiple projects, the build can be made faster. Sorry. Why was I looking for that word faster? I was looking for something else. Speedier. That wasn't the word I was looking for. So right now, main program requires library. We defined library as a project reference in main program. That means we told the compiler, when you compile main program, make sure you have compiled library first, because we're gonna need that code in there. We're gonna need that library, because we use the code in here. So it will first compile library and then compile main program. In this case, library was already compiled. We already compiled the code. We didn't do any changes, so the library we created, the DLL file we created here, is still the same file that we created a minute ago. Unless we make any changes to the code, the same library file can be reused, so we don't need to compile it again. So instead of compiling 2, it just compiled 1 and reused one existing file, making the whole process faster. If there was no dependency between main program and library, if they were truly independent, then in theory could actually compile them both at the same time. That's why we have multi-threading capabilities on our computers. So we can do multiple things at the same time, and if they're truly independent, the compiler doesn't need to wait for one of the other classes to finish or one of the other projects to finish, and we can compile both, making the entire compilation faster. If we actually have a situation where we have a lot of code and compilation times are very long. Sort of a weak statement, but also not really. It's a bit weird. Most projects, most programs you create won't really take all that much time in compilation, but there's a time when your build process as a whole takes on another level because you involve steps that are not just compilation. And even if it's just compilation, there are actually projects that take a really long time to compile. And when I say really long, I mean several seconds. For just direct building, just compilation of pure C# code can take many seconds. I haven't seen any compilations that take minutes, but I've seen builds that take minutes because they have more steps than just compilation that have to happen in between compiling different projects. And so it might speed up the entire build process to spread your code across several projects. It might. Not the best argument. I would say it's the second weakest. So the weakest so far is just I'm organizing my code. The second weakest, I'm speeding up my build process. But at least it's a legitimate one I think can be true, but it's rare. Also, I think there are better ways to handle that. There must be some weird things you're doing that can be sped up in other ways. Maintaining old code that has old features that are not supported in the newer versions, or features that are only supported in new versions that you want to use but can't use in the old one, that's a good reason why you want to have multiple projects. The best reason, however, and I'm saying that as if there are only 4 reasons, there are more, of course, but those are the 4 I care about right now. The best reason is I want to use some piece of code for more than one program. I have other programs I'm writing which might use the same code. Maybe this library, this method here, is so important that many different programs that I'm creating all benefit from it. And in that case, why should I implement the same method as source code in every new program again and again and again? Why not just write it once in one library, like so, and then have all my different programs just imported, reference the existing code. Make my life easier. Makes it easier to maintain, can speed up build times as a benefit, side benefit, but mostly it's about maintenance. You have to write it once, you maintain it in one place, and once you update it in here, all your programs benefit from the update. In theory. That means, of course, you have to now be able to share this library with other programs that might not necessarily be in the same solution. Now, you can have multiple projects in your solution that have dependency on your one project. You can change them together. I could have another project in here that has a dependency on library just as main program. I could also have a library that has a dependency on this project library, and main program has a dependency on this other project, meaning having an indirect dependency on library. Or maybe it could have a dependency on both. The dependency is actually a rather complex topic once you try to solve the issues you have with dependency. Like once you have too many libraries, too many different projects, there are new issues you're facing. More on that later. But you could have a situation where multiple projects in your one solution use one of the other projects. But when I say I want to share my code with other programs, I'm also talking about just sharing the DLL, not the entire project, not the source code, with other programs. I have just this one project, for example, and let's just remove the project dependency here. We can directly edit the project file, that's fine. Our program will not complain because it doesn't know what example class is. It doesn't have namespace library, it doesn't exist. Because we removed the reference to this other project. We can, however, let's go back to this window from earlier. If it will pop up, please pop up. Hello. There we go. We go to browse down here. It's a convenient window for looking for specific libraries you've imported in the past. And I can still go to browse, just could also here go to browse, it's basically the same. Could go to browse and you can see my window because I don't want you to see it, but all I'm doing now is go to the bin directory for library, basically the directory where it will add the DLL and I'm adding the DLL. So I'm not adding the project right now. I'm referencing the library directly. So here's the full path where I found it. Library, this directory is the directory for our project file. Introduction to programming is the solution directory. And in there we have bin, debug, net standard 2.0, and then library DLL. And I've just imported that, not the project. You can see we have a new item group again, but this one looks different. This is not a project reference, this is just a reference for library. Not for a library, but for the file called library. Maybe I should rename this. And actually, if we look in the tree here in Visual Studio, we have dependencies. And we go down here. We can go to libraries and we see, well, to assemblies and we see library with the full path we included. Let's just for reference change this up. Add project reference Let's go to project reference again. If we look at the tree view now, we don't have assemblies, we have project library. Still with a path, but this is a different meaning. This time we include the project that is here. And what I did was just adding the assembly, purely the DLL file. No relation to this project here. Though still we use a relative path because that's the default it tries to do. It by default tries to make a relative path that makes most sense in most cases. But you could also hardcode a path in here to some file somewhere on the computer. And my code will work again because this doesn't care about where the project came from. In the end, it only cares about the DLL file, whether that be directly, like here in assemblies, or through a project reference that has to make sure that this is compiled into something first. In both cases, it will just use the DLL file and allow us to use the code. So I run the code and no exceptions. That's the second way we can add libraries. This one is now independent from having a project in your solution, and it means you can just have some solution somewhere on your computer where you maintain useful code, just some tools or some useful code bases where you think I'm going to reuse this code a lot, and then your actual programs that are seemingly independent from that can have a reference to those files and you can use them. That's the most straightforward way to enable libraries. If you're working with Windows, we should probably mention that quickly. We also have this COM category here. What was it? Something object class? No, class. Was a component class object, component object model, something like that. Can't remember what the acronym was for. But Windows has this system, this COM for short, that allows different languages to share data in between. Simplified. Strongly simplified. But it's just the way I have these objects. Those are registered with Windows in the registry. You actually have to kind of install them in your Windows system. But that means every program on this Windows machine now can understand what those COM objects represent. Just think of a couple of classes that you register in your registry in Windows, specifically Windows, with properties it has and methods it has. And you can use those classes then as if they are part of your code. Works similarly to assemblies. But I'm not going to dive deeper into COM because the topic is complex. At least I think of it as complex. I am not too sure about that myself. I'm using it, but most of the time I'm trying to just get it to work and not think about it further afterwards. Abstraction is a blessing in this case. You know what, let's just have an example, just so you can see it for one. Like a COM reference of... Is there... What's a good example? What's something I know I can use? That should be it. It should be something simple. I think I've used that before, or at least tackled with it. XML. Yeah, that's run. Document. Yeah, whatever. So we have a COM reference now. If we look in the tree, we have this subtree for COM, and we can see the path. The interop, by the way, that's usually what you use. So the COM references that are registered in Windows are not directly what you can use in your language, but when I import this com reference into Visual Studio into my project, it will in the background call some tools that basically generate code that I can use. Like this class here is more or less generated freshly for my project based on the data that is registered. And so I can use it now, interact with it. Looking at the CS project file, this was just added for my com library. Com is a bit weird sometimes, and I'm not going to go into it further. But for the most part, you can think of it as a very special form of I'm sorting out my DLL, because I'm not actually having a DLL I can reference, I'm just using a com reference. And based on that, your system will generate an interop, which is a DLL file you can use. Com is a useful feature, definitely, but it has its quirks, and I don't think it exists on Mac systems. It's definitely not a thing for Linux, to my knowledge. So it's Windows only. Only really use it if you are sure you need it. Now back to importing an assembly file. Right now, I have more or less hard-coded a path to a specific DLL file on my machine, which could be any DLL file, anywhere on my machine. And as long as that DLL file exists and doesn't change, I can use it in my code, write programs, compile, everything works fine. And actually, when I compile my program, it will generate not only my executable, it will also copy the DLL I needed that I used next to my executable. So the output of this program right now is not just a single executable, it's actually an executable plus library.dll. Because my executable, when I started, will actually look for the DLL again. And during compilation, it will ensure that the DLL file is next to your executable and the executable will expect it there. So if you just take the code that I wrote, compile it, you get the executable and the DLL file. If we were to just take the executable away and try to run it, it will not work. Because it's missing the DLL file, library.dll, that it needs to run this code. It cannot start the main method without knowing what example class is. And so it looks for example class, doesn't find an assembly, the DLL file in this case, that contains the code for it, and it will refuse to start. You have to place the DLL file next to it. And the more libraries you use, the more references you add, the more DLLs you will add next to your executable by default. You can also merge them together. So it is absolutely possible to create a single executable that internally contains the library.dll. You can merge libraries together, even after they are already compiled. There are tools for that. But usually you have one file per project, be that an executable or a DLL, and you need them all together to run your program. Now this DLL file, let's say I have 3 or 4 different programs that use the same DLL file, and now I make a bug fix. But this bug fix required me to change something important, like some method cannot just work like this anymore. I have to actually include some parameter, some argument. Less than null, less than 1, then null, else new string let go. Actually, no, null is fine. So I make my change and I adapt my new program to include the parameter. Sure, that's fine. What about my other programs? I was working on this one program, noticed I need to make a bug fix in my library, and I made the bug fix in my library, but I now have to somehow make the other programs aware of that. Otherwise, if I try to compile at some later date, it will just not work. It will just get errors everywhere. And I might not be aware of why. That's something we talked about for attributes already, but in that case, changing it like this, bad idea. You want to keep the old method around if possible. Use some methods. Can do it like that. And to make sure this still does something useful, turn some method on as one that replicates the old behavior. So my old code could still run, my old programs would still work, but I would get the hint that, hey, I should probably switch myself. So that was the obsolete. And there's one more thing you should do to make this easier. What I did right now is change the one DLL file. I forced everyone to make changes to their code. They wouldn't be able to compile their code right now. After I made my changes, if I didn't do this, they would simply not be able to compile. If they needed to make a quick change to their code, they wouldn't be able to push that change out. Because they don't have the original file anymore, they needed to compile their version of the code. They would first need to make all the migration from your old library to your new one. So what you want to do instead, when you make a change to your library, you create another DLL file. You keep the old one around, you just create another DLL file, and you just change the one program that's supposed to use the new file, and you just change the path to the new file. And ideally, you don't just create a new file, you also use a new version for that file. Your executables and DLLs have versions. They have a version number. By default, you don't have to set them, they are already set. Right now I'm using version 1.0. Actually, can I see that in here? That's not the one I wanted. I can't remember, was it in here? Browse. Oh yeah, file version 1.0.0.0. Now I can go to my main program. Let's go to library. I'm just going to add a version specifically. Let's say 1.0.1. I made an update to it. I compile. And if I want to get the update, I can just add a new library and 1.0.1.0. Windows forces the 4-digit version for versions. But the assembly version is 1.0.1. And that way your program can reference a different library with updates, and old programs can still use the old version, the old state of the library. And because you use different version numbers, it's pretty easy for you to distinguish where your code is pointing right now. Now let's talk about NuGet. Just quickly. Maintaining different libraries and different library versions is easy if you have only 1 or 2 libraries and all your code is purely managed by yourself and you have all control over everything. But once you have a larger group of people, or you just have a large number of different projects you're working on, with different libraries, with different states of maintenance, then you need some reliable system to manage all of that. And ideally, you also don't want to constantly use hard-coded path to somewhere on your own file system to organize everything. While there are different ways to handle that, one of the more popular ones, I think, is NuGet, or NuGet. I'm just right-clicking on the project, or I can right-click on the solution and go to Manage NuGet Packages. This is the view I get in Visual Studio. And as a quick overview, on the right side we have package source. There are different sources for NuGet packages. It can be, of course, NuGet.org, which is one of the, or maybe the biggest repository for NuGet packages. Just so you're aware, not all the NuGet packages you can get are free or open source, or both. You would have to check that out yourself before you use one, but for the most part, at least the good ones I used are actually both free and open source. So if you like a version of the library and it's not maintained anymore, you can just make a fork of the Git repository that's usually public and make the fixes yourself, which is pretty useful. But there are also other online sources for packages, and you can also have private sources. Like in our company, we have an internal server that hosts nuggets that are only internal to us. You can also set up very quick package source by pointing to a folder on the file system, so you don't even need the NuGet server or anything. Nuggets also support purely working in file systems, which is pretty cool. It's just a bit more I/O heavy, so a server might be useful, and you can get a very simple NuGet server just for free. Like you can set up a NuGet server project. I think Microsoft actually provides an example for that. So you might want to experiment with that. Anyway, this is the source. This is the singular place where we look for NuGet packages. And a NuGet package is always a combination of a unique name for that package and a version of that package. Right now we are in tab Installed, one of 3 tabs. And this is where we can see all the currently installed NuGet packages, which there are none. If we go to Browse, we can see the entire list of NuGet packages available from our selected source, which is quite a lot. Like I can infinite scroll down here and yeah, don't care about that. Let's say I want to look for something specific. Well, let's use that one. So you can see .NET Framework, which basically Microsoft owned, has this NuGet package. I can select a specific version I want. Let's say I want to just get 9.0.1 for some reason. I can install it. I'm not sure if the window shows up, but it doesn't. Can I show that? That should be it. There you can see it. This is the window that comes up. This will list what it's actually going to install, because NuGet packages have dependencies on their own. Sometimes a NuGet package is like my library, a standalone, you don't need anything more. And sometimes they themselves have dependencies on even further nuggets. Like they reuse code from another NuGet and add their own code. And so you, in order to run their code, need also their own dependency again. So you have dependency of a dependency, indirect dependencies. So besides system drawing common, which we want, we also need Microsoft Win32 system events to make this work. It's also, okay, this is a README, package details, we look in there. It has a couple of dependencies depending on what target version we have, and we can see down here Yep, for .NET 9.0, which we are on, this is what we need. By the way, no dependencies doesn't necessarily mean you don't really need no dependencies. Sometimes it's just empty. Just heads up, but you can do this. Sometimes at this point you would also get another window asking you to confirm the license details, because not all are free and they also have specific license requirements which you would read up on. Oh, don't care about that, sorry. So right here, license is the MIT license, and you can also see the GitHub URL to get the source code for it. If you load NuGet packages and you see them for the first time, please check the license and if you're allowed to use it and potential costs. If you're wondering, usually for the ones that are not for free, you can download them and install them, but then they would require some specific key to use. So you would add a key in your code to make the library work. At least that's how I've seen it done so far. The library itself you can download for free, but you can't actively use it without activating it during runtime using special strings or keys or tokens. And sometimes they require an online connection and are licensed through that. Stuff like that. And now on the third tab, you can also see I have a little one here, because this last tab shows me that for some of the nuggets I have installed, there are updates available, which makes sense. I've installed an older version. So let's just select quickly and update. This entire view also exists for the solution, like so. And if I click on this one now, I can see, oh, it's used for main program, but not for library, which is pretty useful. And something else, we have top level and transitive packages. Because if we look in our CS project file, we have now a package reference. So we had first the project reference to library, then we had just a reference to the DLL, and now we have package reference. You can see which package, the name and its version. And we know this package itself had a dependency on Win32 system events, and that's what we can see in the transitives. So our project also uses Win32 system events. All of these are NuGet packages we are using. It's just this one is one we specifically selected. This one is just thrown in because we have a dependency through drawing.common. So top level statements, this is the ones you actually wanted. Transitive, these are the ones you require to make the ones you want work. And you can also see we have .NET Core platforms and .NET Standard library because of our current setup. .NET Standard library for library here, same as with the .NET Core platforms required for library for the .NET Standard. The common is just used for main program and so is system events. So the overview is quite nice. Also, we can now see a consolidate in the solution-wide view. That's when you have two different projects that use two different versions of a library. And you have to decide which version should you use. Let's not get into that now. But nuggets offer you a way to load libraries like that. If we open this now, we can see another one, another selection down here, another group, packages. So we had projects, we have assemblies, we had COM earlier, and now we have packages for system drawing.common, which also has a dependency on system events. So it's all in here. And now I can use things like graphics from system.drawing. This is also where things can get a bit ugly, with NuGet packages and dependencies on dependencies on dependencies, or the transitive dependencies. You can have a situation where, let's say I require two different libraries, two different nuggets, but those two nuggets I need require both require one specific third NuGet. So I have two top-level requirements, two direct NuGets I need, two libraries, but they both require to work a third library that you don't really care about yourself, but you include it because those two libraries need it. Well, what if library A and library B need different versions of that third library? Well, library A might be a bit older and require an older version, and library B might require a newer version, and those versions are not compatible, so you can't just choose the newer version and everything works. That's the kind of issue you run into once you have multiple libraries that you have to manage and different combinations of libraries you have to manage and different programs that require different combinations of different libraries. I don't have a solution for situations like that, by the way. We had that happen a few times, and we just adapted our code to get a version of library A and library B that did align, which meant doing a beta version of A and an older version of B, so you just barely overlapped with the requirements everywhere so our code could run. It's a bit shaky, but it works. But by God, is it hurting my brain sometimes. Okay, so far NuGets. NuGets, you can create NuGet packages yourself. I mentioned we have private NuGet sources you can make yourself, but that is a bit more involved. I'm not gonna get into that because NuGets is not really a topic we need to talk about. Like using NuGets, sure, but creating them yourself. At least if you want to make something useful, you should be aware of all the different options you have with NuGets and the different configurations you can make and the different ways you can create them. Because some are built in. You could add stuff in here in this project file. Should be kind of... you can see it? Yeah, it's a tab. So we have this package where you can actually define stuff to automatically have a NuGet package created. Like this package refers to NuGet packages. But there are limits to what you can set up with that. And external programs have their own little quirks, and yeah. I'm not gonna get into that. I don't understand enough about it to confidently tell you how to use it or give you advice. Now, after showing you these options, there's only one more way we need to talk about. How often in your career have you ever had the need to use shell sorting? I don't think I've ever used it. I mean, maybe indirectly because some library I use it internally. I've never consciously did it. The only sorting algorithm I'm aware of using, at least, was just a quick sort, because that was the default that's implemented already. And I think I had to make a custom insertion sort at some point. Well, it's useful to know that stuff. Sorting is just you might not use these sorting algorithms, but the approach of, hey, here's a sorting algorithm, it's simple to understand, and it's a good example for how to calculate things like big O. Figure that stuff out. Like, I think it's just so you have some examples to work with, not because you actually need the sorting algorithm themselves. I kind of feel your pain, I've been through the same. I can't remember most of this stuff in terms of algorithms. I remember I had to implement red-black trees back then. Never used them so far. I tried at some point, but I couldn't figure it out of my head, and I didn't bother reading up how to actually re-implement a red-black tree again. I was quite proud of myself back then. Yeah, sometimes it's like that. It's more about just having examples to work with and learn, less about you need to know this to get your job done. It's not practical, it's more one possible way to apply some more general knowledge. How to figure out an algorithm, how to prove that it works, how to assess the performance, how to compare algorithms. Sorting is just very easy to understand, very easy visuals. Data structure. Yeah, Data Structures und Algorithms. Datenstrukturen und Algorithmen? Habe ich das Buch noch? I should probably look up if I have still some of my old books. Maybe a fun way to spend an afternoon reading up on that stuff. Alright. Where was I? Libraries. So we had assemblies, direct reference to an assembly. We had project references. We have packages. We have com. Right. And the last one. So far, all the DLLs we've implemented or imported through whatever way were written in C#, or at least were .NET libraries. You're not limited to that. I mean, COM libraries are already kind of the gray zone because the COM definitions themselves are basically language agnostic, and the interops are C#, but they are generated on the fly for those COM libraries. But there's another way you can implement a reference to a library that is happening during runtime, that you don't have to do in your project settings. And you can even reference libraries that were not written in C#. So, for example, written in C. And very useful is when you use libraries that are written in C or C++ that come with your operating system and that you can actually call to make some really cool features work, because you don't have to work through what the standard system libraries provide you with, the interfaces. You can just directly go to Windows and tell it, please do this thing. It's a bit more involved. Actually, let's wait for that. Let's make one example. Yeah, let's go with that. I think that's a good example. I'm gonna call this private. I can also make this public or protected or whatever. But, yeah, protected no. But I can make this also public. I'm gonna keep it private because these calls to external libraries require some specific knowledge, and usually I don't want other classes, other code, other parts of my code to interact with those libraries directly. I prefer to keep them private and write safe code in my class that internally references these private methods that I'm going to write here. And that way I can make sure that the code is reused correctly. And private static, they're always static. Actually, no, they're not always static. In this case, it's static. Extern, I've only ever used static extern. Extern for external, just reference that we are not using managed code anymore. We're not using the .NET DLL code that we might actually have source code for. We reference now just a DLL, which has code in it that we can call. There's endpoints we can reach, written in some language that is capable of creating a DLL. Because DLLs are kind of a standardized format that is not unique to .NET or C#. And static extern, now I have to look up what the, I cannot remember the name. I think it was something like get mouse position. I have to look up that. Wait, where was it? No, it's not here. Yeah, static is, you can call that method directly. I know that extern can be used. There are external calls that don't use static as far as I know, but I've never interacted with that, so I'm not sure what rules apply in there. Might be a weird overlap between com and... no, that must make sense. I've only ever used the extern with static. Not sure how extern works with non-statics. And I can't... why is it... Okay, let's use it the hard way. Just go app data. That should work. Was it in source here? Source? No. Roaming? Where did I put those files? Oh, it was in app data directly. Okay, I was just blind. And that was in here. Let me put that to the side. There it is. And cursor position, not mouse. That was it. Okay. So return value is a bool, get cursor plus. And the thing is, with these external calls, we have to specify the name that was already given to the method. Usually, I determine what name I want to use for that method. In this case, however, I can't. I have to use the actual name of the method I want to call when I define this method, kind of. Now things get a bit weirder. This has an out variable, and there's currently no type in our... Actually, there would be a type, but let's create our own that can read the data. So, because we're interacting with just general libraries outside of our program, not with the C# program, we're not limited to C# types anymore. We just have to work with just more generalized blobs of data that can mean anything. And you have to read up on what exactly is the data you get back. And in this case, I know what I get back is a sequence of 64 bits that represent two 32-bit integer numbers. And I get that as an out variable. So now I have to provide a type in here that C# can use that internally also represents just two 32-bit integers, unsigned integers. And the easiest way to do that is with a struct. Let's just call it cursor position. And it's gonna have a uint, 32-bit, unsigned, x, and a y. X and y positions. So I can have that now as a cursor position. It's an out variable. And the return value of this method is a bool, which is the same in the general blob. It's just 0 or 1 or not 0. It's just a yes or no, which in C# is not a 1 or 0, but it's translated into that. So this works fine. We can just use bool. Cursor position has to be special because we want to create a sequence of bits that are total 64 bits. The first 32 bits represent one integer. The last 32 bits replace what? Okay, so we're gonna make... So I was asked to explain this part. Get cursor position is going to be a method call in an external library. A library that's not written in C#. Is written in, I believe it's just C. Either C or C++ in this case. It's one of the basic Windows DLLs. And because we're just interacting with a library in general, a DLL on a general level, the data we feed into the method calls and the data we get back from those method calls into this very specific non-C# DLL, they don't have the same types as C# uses, not necessarily. That means the structure for the different bits are arranged in a different way to what we might be used to. In this case, we know what the method actually returns in this out variable will be a sequence of 64 bits. That is officially defined. And these 64 bits that will be returned are a combination of two 32-bit unsigned integers. That's how the method is officially defined. What is defined and what not, and how the method works, is something you would have to read up for each method you want to call. So in this case, this is a very specific method in the Windows API that we're calling. There are Windows documentations for that will tell us what the return value will be. And it's two 32-bit unsigned integers. One blob of 64 bits. And we have to somehow translate this one continuous sequence of 64 bits into a type that is understood by C#. And now we have to just create some structure that is equally made up of two 32-bit unsigned integers to create one whole 64-bit sequence that represents two different values. And the easiest way to do that is through a struct, because structs are fundamentally just bit sequences put together. We have a bit sequence for an unsigned integer called x, and we follow that up with an unsigned integer y. So in the memory, it will just mash these two 32-bit numbers together to one large 64-bit structure. And only by knowing what the cursor position is do we split up the 64 bits into two 32-bit numbers. In theory, you could also do something like public byte A, public byte B, public byte C. So this would be now a structure that has in total 24 bits in memory. A sequence of 24 bits in memory, where the first 8-bit represents this A, the next 8-bit, the middle part, represents B, and the last part represents C. 8-bit, 8-bit, 8-bit for a total of 24-bit for the entire struct. And the method we get here has a total of 64 bits, 32 and 32. That's officially defined for the DLL we're going to call. And to match that, I'm creating a struct that also has 32-bit and 32-bit. The first one is representing an x coordinate, and the next one is representing a y coordinate. So I'm just providing a C# representation for 64 bits, which combines two 32-bit numbers. And I'm telling C#, I'm telling my runtime to just take the bit sequence we get from the external DLL as is, just take the bit sequence directly and just pretend it is this struct here. It is a struct of this type. Interpret the 64 bits you get as if it was cursor position. And that's how we can get the translation from the type that the external DLL uses into a type that we use in our C# program. Does that make more sense? I might have over-explained it a bit. Well, glad it came through. So, with this line, we've basically just defined a method inside an external library that will return a boolean directly and have an out variable, so also return another value, which we just wrap inside a cursor position. Again, we just get bits back. It's an external call. We just get random bits back that have no relation to any C# types. We don't know what they mean. So inside this one line, we tell C# or tell the runtime, interpret the direct return value as a bool, which it will do, and it will magically work in this case. And we also tell it, pretend that the bits you get back from the out variable are a cursor position. And we've set up cursor position in a way that it will line up correctly. I could also just go for long in here. In theory, I could also put long in here directly. It will still fulfill the criteria of we get 64-bit back and you have to store them in something. And we can tell it, just pretend this long is the return value. That would work as well. But we know the data internally is meant to be two different unsigned integers, and by wrapping them in the struct, we have a way of addressing them easily, instead of having one 64-bit number, long, which we then would have to manipulate with bit operations to get individual parts of. And now comes a very important attribute, because we need to tell the system now where it can find this method. We need to define a library for that. And there's this thing called DllImport, which is pretty on the nose. We're importing a DLL. And because we're using a standard Windows DLL, I just have to put in the name of the DLL and it will automatically find the correct library. We could also do something else, but I've never done that, so we're focusing on just the basic Windows calls, in this case user32.dll. This is a default library that Windows provides. It's part of the standard Windows APIs. Has lots of other functions as well, and you can find documentations online. I find them hard to navigate, to find, but you can do that. And I think it's written in C, but we told the system Windows has a library called user32, and in that library you will find a method called getCursorPos. Call that method. And then wrap the results we get in a bool and a cursor position. Just pretend they're the correct type. And now I can do getCursorPosition. Wait, that's not it. That's not it. Cursor position like that. Okay, we can check the bool, but I don't really care about that bool, to be honest. It's part of the definition. And cursor position, we have now an X and a Y, and let's just put it in the debug output. Position.x and position.y. So I'm placing my cursor right here next to program. Actually, can you see the cursor? Yeah, I can see it. You can see a little. This is where my cursor is right now. I'm pressing just F5. And now you can see down here, X is 518, Y is 320. Now I'm placing my cursor down here in the bottom right. I'm pressing F5. 1402, 666. This method reads my current cursor position. This is a way you can directly ask the Windows system, hey, where is currently my mouse cursor? And if I put this in a loop, I can constantly track where my cursor is. So how do we actually, let's just do forever loop. While true. Like this. Let's just be lazy. Position.y. And let's put a bit of delay in there, but don't sleep. Let's do 100 milliseconds, so 10 times per second it will check now. And output. You should still see my cursor correspond to changes. My mouse cursor, specifically, horizontally and vertically. I'm not speeding this up because the debug output isn't the fastest, but the frame rates are a lot higher if you need that. And by the way, again, we can do that as well. You can just get long position. But this is just the 64 bits we get back from the system, interpreted as, actually, let's use ulong, unsigned. Interpreted as a long, which doesn't make all that much sense anymore, because it is actually two numbers just right next to each other in memory. And if I try to do something that doesn't work, like integer, F5, well, that still works. Didn't know that. I thought it would crash. I was hoping it would crash. Okay, it's just cutting off the first bits it finds and uses the rest. Oh, when is this preferred compared to NuGets or other situations? Honestly, the only reason I would use this is because I want to directly access a Windows feature of the underlying operating system in general. Either for performance reasons maybe, because the library you're using would have several layers of abstraction between you and the access code, or the access to a method, or because there is no library that provides that specific feature that you need. Good example would be, it's been a while, but there's, if you're using Windows Forms or WPF or any of the Windows features, window feature, any UI design, and you use the default Windows folder dialog, which is just a very convenient way for you to quickly say, Windows, please show the user a dialog to select some folder on their operating system, or on their file system. The default was just a simple tree view and not the normal file explorer window you used to when you select files. So we had the file selection as well with the full featured file explorer, but the old folder selection was just a very simple, annoying tree view, very limited in features. But that was when you used the WinForms libraries. So instead, we used the calls to the Windows API directly to access the actual folder selection that was available in Windows, just not exposed through the APIs, through the NuGets or the libraries for WinForms. Nowadays, the full featured folder selection is available, so we don't need that anymore, but back then, we used DllImport to get the underlying features, to get access to the flags that we needed to change a file selection window into folder selection. So that. Usually, maybe for performance reasons, though I'm not sure if this has any performance penalties, or because you have no other way to get to the feature. So that's how you do that. Let's see. Actually, we're not too far. Actually, want to show something cool I recently learned. There's another, I'm just copying some code over here, because it blew me away back then. This is another import. This one is to kernel 32, still Windows DLL, standard stuff. The method is called getConsoleWindow, and it returns an int pointer, which is a struct, by the way. And if you start using int pointers, you know you're in dangerous territory. So if you ever work with libraries and you see int pointer, be careful what you're doing, because you're doing some very special stuff now. Like stuff that usually is hidden behind abstractions. But it allows you to do some cool stuff, like, since we imported the graphics already through the drawing NuGet from, yeah. Let's say getConsoleWindow. So this will call the Windows API to get a pointer, well, not pointer, sort of like a pointer, a reference to the console we're starting with the program. So when we start the console, this console is a window we see, And we're getting a reference to this window that is used by the operating system itself. And we can then use this to reference our window when using this graphics object from the drawing.common console window. And we're gonna grab that in the using, like that. And then we can use the graphics object to a rectangle, new pen, color, just use blue. Rectangle, no, it's not bother with a rectangle. Let's just use 10, 10, and then let's make it 400 by 300 pixel. This will draw a rectangle, and then console.read key. True. This should do the trick. Did I forget something? All right, I should now change this to .NET 9. These are very specific Windows features I'm using now. So I'm limiting my program to Windows directly. This is a larger topic. We don't need to think about that. For now, this is just so I can make this code work. And if I run my program, you cannot see the window. Why not? Let's change this. Yeah, you can see it. So let's make leap. That's maybe 1, 2, 3. It's maybe different windows. And wait, rectangle. How do I fill that? Filled. Was it in the pen? Width? Let's just use a bigger width. And like that. And this one will get red and maybe 50, 50, and just 40, 30. So we don't even need any WinForms reference or something. We can just draw directly in our console. Even though this is a pure console program, as you can see with the text, but we can draw with it, in it, using just the reference, which I thought was pretty cool. You can even draw it directly to the screen. I always thought you need some special privileges from the Windows system directly. Apparently you didn't. That was new to me. I never tried it. I always used external libraries to draw stuff. Then recently I tried something and I can use my console. I don't need to make a WinForms project just because I want to draw something, which is... But yeah, stuff like this can be done pretty easily just using DllImport, extern call. I don't need to import any big libraries. So in this case I did need to import the system drawing common because it contains the graphics class, which handles all the complicated stuff for actually drawing stuff. So that's nice. And last but not least, just to get some basics out, we should finally talk about the accessors that we've used all the time. And for that, let me just quickly change the project again. Am I blind? Okay, let's change to library. And boom. I mean, I could just go into the CS project as well, but oh well. Make a library reference to make our life a bit easier. So this is example class. We have public string sum method, and then we have an internal method, some method internal, some method public, then we have some method protected, and at least what used to be the big four. And these accessors apply to fields and properties, of course, as well. 3D objects. I mean, if you have the rendering engine for that, of course. In the end, the 3D objects are just mapped onto 2D plane, right? You just render them into 2D and draw that 2D image. So if your library can handle 3D objects and render them, yeah, I mean, in the end, all you need to do is get the 2D image and then you can draw in your console or wherever. I just don't know any pre-existing simple 3D libraries. I think if I want to do 3D, I would always just refer to one of the big game engines to make my life easier. Like for C#, maybe then Unity. Actually, how is Unity these days? They used to have this big issue with the license, right? Where suddenly everyone had to pay enormous sums. Did they sort that out at any point? Ah, well, I'm not actually using Unity, so it's not important for me right now. Example class. So, private means it's limited to the scope we define it in. We talked about that. So private is only accessible within this class. I can reference it from anywhere in here. So with private, no problem, but I'm not able to reference it from somewhere else. So example class dot some method public, it's available, but not private. And public means, of course, everyone can see it everywhere. Now, protected is something we talked about before. If I have public class child, which inherits what's happening to my keyboard? Inherits from example class, then public void call protected, then I can do some method protected. So protected means it's not just limited to the class itself, like private, it's like private but also within the class that inherits from us. Alright? Now internal is a new one that never applied before because we never left the one project realm. Internal just means like public, but only within my project. So some method internal, perfectly viable to call from anywhere else. Public, set a class, another, and then public static void test, sample class dot some method internal. No problem. It's visible, we can call it like a public, but we can't call it from here. Example class dot public is the only one we can see. That's the meaning of internal, the last of the big four ones. Yeah, protected means it's private to the base class where it's defined, and also private to all the classes where you inherit. So protected means only I, the class itself, and my child classes can see this method. Protected means only I can see it. Public means everyone can see it, and internal would be everyone inside my assembly can see it. And for us, assembly, at least for now, means the project itself. At least that's how it used to be. These were the big four. And then we got some new accessors, 3 in fact, that do some interesting stuff. We now have, for example, not just protected, we also have private protected. Private protected. Now, private protected doesn't exist, as far as we have here. We inherit from example class, but we can't see private protected. We can only see protected. Private protected is an extension, or it's like a mix of protected and internal, despite its name. And it basically means only I can see it, the class itself, and all my child classes that are also in the same assembly. So if I take this code, put this in here, no problem. And here, problem. Can we use a private through interface? No. If you implement an interface, those methods have to be made available outside. Like, if I have an interface, let's start with a classic interface, public interface, public. I don't have any accessors inside my interface. They're not a thing, they're just definitions for I need a method. Void interface method that, and then my example class I'm public. Now when I implement the method in example class and I try to make it private void interface method, I get an error because I am public is a public interface. So everyone that sees my example class will also see that example class inherits from I am public, and so example class offers all the interface methods, or example class offers all the interface methods that are defined in I am public. If I make this private, I wouldn't be able to access the interface method, so I'm contradicting this rule. I say I am public and I offer all the methods that come with it, but then I hide the method, so I don't come with it. So I might as well not interface or implement the interface at all. If I offer the interface, I have to make the accessor at least as accessible as the interface itself. So in this case, public. If this is internal, which is a bit more limited, internal means everyone in my assembly can see me, but someone outside of my assembly doesn't know I exist. So program, the other assembly, the other project doesn't know this interface exists. So I can try to make this internal, and this still doesn't work because example is public. And I'm getting things mixed up. Yeah, I have to make it public. What were the rules again? No, I know there was a way to make that hidden. But don't implement that. God, what was it? Or was that with not interfaces but classes? That might have been with classes, not interfaces. If I inherit from a class, then I had ways to make that more hidden. As long as everyone else sees the same. Hello. So yeah. Basic rule is, if the interface says I have the method, then you need to have the method. So making it private doesn't work. Yeah, so the most important one was private, protected, internal, public. And private protected is one of the new ones. And oh god, there was another one. There were two ones. There's also file, which is very specific and you don't need to know that one. There was another one with protected. Was it protected internal? I think that was it. But I never used that one. Protected internal. Like that. And this one is actually more what it says. It's like internal. So I can, if I just do, let's go for, so if I have just any other class in the same assembly, should be able to some method protected internal. So inside my assembly, it behaves just like an internal method, but it allows me to also inherit outside of my assembly. So private protected means I can only see it in my class and children and only within the assembly. And protected internal means I can see it everywhere in my assembly and I can see it outside my assembly when I inherit it, like protected. And yeah, there's technically a third one, new one. I think it was just file. No, it was, how did that work? Can't remember. I think it was file something, or maybe that was a beta feature for a new version. That would limit the accessibility through the file. So all these three classes would be able to see it because they're in the same .cs file. Very specific use case, don't need to know about that one. And usually the big four are enough. Private, protected, internal, public. These combined ones are potentially useful, but weird. But talking about the, let's remove this. There's something interesting you can do with accessibility and interfaces though. Sometimes, this is a combination I sometimes use actually. It's not directly about methods, but I can have, say, a public interface. I save use, do that, void do something. So that one. And then I have a private class in here. Private hidden and unsafe. Unsafe, which inherits from I save use, which does have to do a public do something, which is not doing anything right now. Let's ignore that. But maybe it also does something like public void for internal use only. So I have this internal class that I don't want other code to directly use because it is not directly safe. There are important sensitive parts in this class that should not be touched by code that doesn't fully understand it. So even if I write the code myself, I want to avoid accidentally using internal methods that I shouldn't touch. But I still want people to use the class as a whole because this method is something they need to use. So the class itself is something I might need to use outside, but only part of it. And I can do that through an interface because the class itself is hidden, and I can do public static I save use, get save version, and return new hidden and safe. So if I were to use the class in here, I would have access to hidden and safe for internal use only. But someone else, let's just remove all of this. How did I arrange this? Example class, no, I don't care about that right now. Example class and then get save version, yep. Class dot, why is it not here? Because, okay, what am I missing? Oh, right. Was static. So I save version. Save version only has to do something. If I try to call the same method in here, I would get an error. So this is something you can do for accessibility with interfaces. That is quite interesting. Internally, I have the full access to this class, including the somewhat unsafe methods and properties and fields and whatnot. But by only exposing it through the interface to the outside world, I can make sure that nobody can use the unsafe parts. And all they see is this interface implementation and they don't know what's actually behind it. They can't just create this class themselves, they can't just use the class in any way they want to, only in a way that fits my needs. Okay, the last part was a bit boring. But that's it for external libraries. So we have the option to exclude external libraries and external projects. And inside a C# solution, we can just reference other projects directly. We can also reference assemblies directly as loading DLL files. We have the special case of COM interfaces, which are a unique case that in the end are just wrapped inside a C# class we load, similar to loading assembly. We have NuGets, which are just, again, loading assembly files, DLLs, but they offer a way to manage them better by giving them unique names and strict versioning to make sure that you only use the one version of the library that you actually need, and it helps you with organizing everything. And lastly, we had the extern call, which lets you interact with DLLs that are not written for C# directly, and that also lets you use predominantly the API features of the Windows operating system directly, or whatever other libraries you have. All right. Homework. Take one project you've written in the past and try to split that up into one actual program that's executed and one project that's purely library code. And then try to reduce the surface area of that library by using accessors that match what you actually need. Make sure that things are private if they need to be private, or internal if they only need to be internal, and only use public where you actually need to make them public. Try to design a library that's safe to use and can be reused for other parts of your code, other projects. Right, that's it for today. See you next time.